A square loop of wire, 50 centimeters on each side, is in a 2 Tesla magnetic field. For part A, what is the minimum value of the magnetic flux that can pass through this loop, and what angle should the loop be oriented to achieve that flux? The minimum value of the magnetic flux is equal to 0. And according to the equation for magnetic flux, which is B times A times the cosine of theta, if you have a magnetic field and the loop has an area, the only way to get this to equal to 0 is if the cosine theta itself is equal to 0. And that occurs when theta is equal to 90 degrees. But keep in mind that the theta is the angle between the normal and the magnetic field. And the normal is perpendicular to the area, which means that the area of the loop itself should be 0 degrees from the magnetic field, which is the B. In part B, what is the maximum value of the magnetic flux that can pass through the loop? So the maximum value would occur when the cosine of theta is equal to 1. So the maximum value is just going to be B times A, which in this case, the B was given as 2 Tesla times the area. It's a square loop, 50 centimeters on each side, which is 0.5 meters. So 0.5 squared, and that gives you a magnetic flux of 0.5 Webers. In order to get this to happen, the cosine of theta has to equal 1, so that means that theta is equal to 0 degrees. But again, that's the angle between the normal and the magnetic field, which means the area of the loop has to be 90 degrees from the magnetic field. And in part C, at what angle should the area of the loop be oriented with the magnetic field so that the flux is halfway between the minimum and the maximum values? Well, if the minimum value is 0 and the maximum value is 0.5, that means we're trying to achieve a magnetic flux of halfway between those, which is 0.25 Webers. Now, a lot of people are just inclined to say, well, the halfway point means the angle is going to be halfway, which is at 45 degrees. But that is wrong. You have to go through and solve this to get it. So if we rearrange this equation for the magnetic flux to get theta by itself, divide both sides by the BA. So we have that is equal to cosine of theta, and then we need to take the inverse cosine of both sides. So theta is equal to the inverse cosine of the magnetic flux over BA. So the inverse cosine of the magnetic flux we just said was 0.25, and B times A we solved for up here, so I can put a 0.5 down the bottom. So that's the inverse cosine of 1/2, which is equal to 60 degrees. But keep in mind again, that is the angle between the normal and the magnetic field, which means the area would have to be 30 degrees from the magnetic field.